Greetings of the day, dear students. In this video, we are going to discuss about one important test, that is the short circuit test or impedance test. Right now, we are going to discuss its circuit diagram, how the meters are connected, and which side the test is to be performed, and also the purpose of this test. What is the main purpose? How to calculate its equivalent impedance, equivalent reactance, and equivalent resistance, how the copper losses are calculated for a full load, and how to represent the circuit with respect to the primary side, and also we will discuss one small example with related to this topic in this video. Right, dear students, please observe with respect to the short circuit or impedance test. What happens is, for a given transformer, the low voltage winding, the LV side, is to be short circuited. This is very important. The low voltage or LV side of the transformer is to be short circuited. Now whatever the meters are there, the ammeter, voltmeter and wattmeter will be connected on HV side, or to be connected on HV side. Now ammeter will be connected in series with the HV winding, voltmeter is connected in parallel across the HV winding, and the wattmeter current coil in series and the potential coil will be in parallel with the HV winding. Right now, using this test, what we can do is we can find out its equivalent impedance Z01, equivalent reactance X01, and the equivalent resistance R01 referred to one side of the circuit. Here in this context, it is with respect to the HV side. Now, using this test, the copper losses at full load can be calculated. So using these losses, we can also calculate the efficiency of the transformer. So this is the main purpose of conducting this short circuit test. Right? Yeah. Now observe, while performing this test, what happens is, you should be very cautious while performing this short circuit test in the laboratory. If you are having this experiment in your curriculum, right, very small amount of voltage, it will be normally some 5 to 10% of the rated voltage of the HV side will be enough, okay, to for the transformer to draw the rated current. Right, so you should be very cautious while wearing the variac in your laboratory. Slowly you have to vary such that with the help of some 5 to 10% of its rated voltage itself, we will get the high amount of current, rated current. Slowly you have to keep varying the variac until you get the rated current. Right now, because of the applied voltage is very small, for a very small amount of voltage, applied voltage, we are getting the rated current. The mutual flux is also will be very small percentage of the normal value. Now whatever the losses that occurs, that will represents the full load copper losses. If you observe in open circuit test, as there is no load, whatever the losses have occurred, they are representing the core losses. Right now, here in this short circuit test, the core losses will be very small. Now the wattmeter readings will represent the full load copper loss or I square losses for the whole transformer. This is important point. Right now, from that test data, from the, if for example, if VSC is the applied voltage, which is normally some 5 to 10% of its rated value, then based upon the voltmeter reading and ammeter reading, Z01 is calculated as VSC by I1, and the wattmeter reading will be equals to the I square R01, I1 square R01. From that we can obtain R01 equals to wattmeter reading divided by I1 square. Now once you know X01, once you know the Z01 and R01, it is very easy for us to calculate the reactance. X01 is given by root over Z01 square minus R01 square. R01 square will give you the X01. Right now, if we can measure, R1 is measured, and now by knowing R01, R2 dash is simply given by R01 minus R1, R01 minus R1. Now if you do a small example, we will better understand how to calculate all those things, right? Dear students, please observe, obtain the equivalent circuit of a 200 by 400 volt 50H single phase transformer from following test data. From open circuit test, 200 volt, zero point 7 amps, 70 watt on LV side, and from short circuit test, 15 volt, 10 amps, 85 watt on HV side, right? So dear students, please observe, from open circuit test, the representation of variables are important. V1, LV side voltage 200 volt, no load current I naught, it is to be represented with variable I naught, zero point 0.7, wattmeter reading 70 watt, right? Now already we know from short circuit test from open circuit test, wattmeter reading equals to V1 I naught cos phi naught. From that, cos phi naught equals to wattmeter reading by V1 I naught, which is simply 70 divided by 200 into 0.7. We used to get 0.5. Once you know cos phi naught, sin phi naught is obtained by phi naught equals to, phi naught will be cos inverse of 0.5, right? We will get the angle. Now if you substitute that angle in sin phi naught, we will get 0.866, right? Once we know cos phi naught and sin phi naught, this I naught can be resolved into two components. One is the magnetizing component I mu, and another one is the working component. So IW is given by I naught cos phi naught, it is 0.35 amps. I mu equals to I naught sin phi naught, it is equals to 0.606 amps. So from this open circuit test, we have calculated IW and I mu. IW and I mu. Right? Now, observe. But what about R naught? It is simply V1 divided by I mu, IW. Like this, we are having R naught, X naught. Now this R naught, X naught value you are supposed to calculate. This is I naught, right? This is IW working component, and this is IU magnetizing component. Now R naught is obtained by V1 divided by IW. It is simply 571.4 ohms. X naught V1 divided by I mu, 200 divided by 0.606, it is 330 ohms, right? Now from short circuit test, we will get the overall impedance Z02. Refer Z02 is simply obtained by VSC by I2. It is 15 divided by 10, 1.5 ohms, right? Now the from transformation ratio N2 by N1 or V2 by V1, right? 400 by 200, it is 2. Now what about Z01? Z02 by K square, refer to the primary. Z02 by K square, 1.5 divided by 2 square, it is 0.375 ohms. Now what about wattmeter reading? I2 square R naught 2, I2 square R naught 2 from short circuit test, I2 square R naught 2. Now R naught 2 will be equals to the wattmeter reading divided by I2 square, 85 divided by 100, 0.85 ohms. So now once we know R naught 2, it is easy for us to calculate R naught 1. R naught 2 by divided by K square, 0.85 by 4, it is 0.21 ohms. Similarly, reactance X naught 1 is obtained by root over Z naught square minus R naught 1 square. Z naught 1 square we have calculated 0.375 square minus 0.21 square, we will get 0.31. Now representing all these parameters with respect to the primary side, R naught 1 is 0.21, X naught 1 0.31 ohms, and and we have resolved I1 into I naught. No, sorry, I naught is resolved into two components. Magnetizing component, working component, we have found R naught and we have found X naught, 571.4 ohms and 330 ohms, and this is the primary side applied voltage and V2 dash, right? This is how we can draw the equivalent circuit diagram from the given test data. Clear? Thank you.